These are the angle theorems that you explored in class. And these angle theorems fall out from the parallel postulates. So the first thing is we need some definitions. One of the angles that we talk about are vertical angles. And vertical angles are angles that are formed, opposite angles that are formed at the point of intersection of two lines. So angle 1 is vertical with angle 3, and angle 4 is vertical with angle 2. And then our theorem actually says that vertical angles are congruent. So we now not only can say that 1 and 3 are vertical, we can actually say that angle 1 is congruent to angle 3, and that angle 4 is congruent to angle 2. Another theorem that we have talks about the exterior angle in a triangle. And it turns out that our theorem says that the exterior angle of a triangle is equal to the sum of the remote interior angles, which, if I'm using a diagram, becomes a little bit clearer when I simply say that angle A is, the measure of angle A is equal to the measure of angle C plus the measure of angle D. So just to highlight here, this is our exterior angle right here. And our remote meaning farther away, interior meaning inside angles are C and D. For the rest of our angle theorems, we need to define something called a transversal. So a transversal is a line that intersects two or more lines, and we call it a transversal. So right here we have a transversal and we have a transversal. Now transversals can cut through parallel lines, as this one does. These are parallel. Or it can cut through lines that are not parallel, as in figure B. So now we're going to talk about, however, corresponding angles and alternate interior angles and same side interior angles. And we're going to talk about them always in terms of parallel lines cut by a transversal. So the first thing we're going to do is we're going to identify some pairs of corresponding angles. So corresponding angles are angles that sit in the same place. So if you can imagine taking this line, and this transversal, and sliding them on top of each other, they're going to be the angles that end up on top of each other. So we would say that angle 2 and angle 6, angle 4 and angle 8, angle 1 and angle 5, and angle 7 and angle 3. And then we actually have a theorem that we've proven that says corresponding angles sorry, let me just get my language exactly right. Corresponding angles formed by parallel lines cut by a transversal are congruent. So now, if I say that these two lines are parallel, I can actually change each and every one of these statements. So if parallel, I can then change all of these to be that angle 2 is congruent to angle 6, angle 4 is congruent to angle 8, angle 1 is congruent to angle 5, angle 3 is congruent to angle 7. My next triangle congruence statement, my next angle theorem that I want to talk about is alternate interior angles. So the first thing we're going to do here is we're going to identify alternate interior. So alternate interior, meaning alternate opposite sides. Interior, meaning inside. So I'm looking at the 4 inside angles right here, interior. And I'm looking at the opposites. So I'm looking at 3 and 6 and 5 and 4. So angle 3 and angle 6 are alternate interior, as are angle 4 and angle 5. Now again, we have a theorem that says if two parallel lines are cut by a transversal, then alternate, oops, let's make sure I spell this right. There we go. Alternate interior angles are congruent. So again, if I go back to this and I say if parallel, then these actually turn into the statements that angle 3 is congruent to angle 6 and angle 4 is congruent to angle 5. The last one we're going to talk about is same side interior angles. So we're still talking about interior, so that's these 4 on the inside, but now we're talking about the same side, meaning that they're on the same, they share the line. So we can see that 5 and 6 share a line, and 3 and 4 share a line. And we can say that, oh, sorry, I actually have done this the wrong way. I apologize profusely. We actually want to look at the same side of the transversal. I am so sorry. Scratch that for a moment. Let me rewrite in these lines. So what I'm actually looking at here is I'm looking at the same side of the transversal. So pair of, oh, this is a typo, it should say pair of same side interior angles. I'll fix that on the document that I upload though, so you won't have to fix that. It'll be correct when you read it. Pairs of same side interior angles in the figure. So that's angle 3 and angle 5. And angle 4 with angle 6. And our theorem says if two parallel lines are cut by a transversal, then same side interior angles are supplementary. So if I go back here and I say, well, if these lines are parallel, then these statements actually turn into that angle 3, the measure of angle 3 plus the measure of angle 5 equals 180 degrees. And the measure of angle 4 plus the measure of angle 6 equals 180 degrees.